Hello everyone, welcome to our home. This is one way in which we're going to proceed. This is my living room. These are blackboards that I've been hauling around for 10 years. And as I mentioned in the PowerPoint, this is one of several ways that we're going to be in communication. This is how we're going to transfer notes. For example, today, let's do section 6.3. Even though we pretty much did it before you left, this is called determining probabilities. And the homework that is assigned, homework is on page 271. I assign specific problems. It really doesn't matter. They're all the same. You just do a couple of them. Just make sure you can do them. Again, they're all A, B, C, D. B, C, D. It's a lot of homework. But that's where the homework is, and we'll talk about that after today. So let's go back to determining probabilities. Just recall. There's 4 types: less than, greater than, between, and what I call extremes. There's 4 types of probability. So you're looking at an x value. These are x values. So suppose the data point was less than the x value. Put it, say, here, and less than would be all that area over there. Versus, or it could actually be over here, and it'd be even more area. Note that's more than 50%. Less than 50%, more than 50%. Greater than, it's just the other way around. Greater than. Between, normal curve, womp womp, between 2 values. Note you have to do 2 of them and subtract. Extremes, oh boy, I'm getting low. This one, whoops, plus that one. Notice you have to do 2, you have to look up 2 probabilities, then you add. So in order to do these, I guess, let's give you some direction. Read and understand. Problem. Read and understand the problem. And in order to do that, you want to identify the mean and the standard D. This will be mu, and that's, of course, a sigma. And as you're doing that, you want to identify the data point of interest. The data point. X value of interest. And right here, you should know which table you're going to look it up. You should know whether it's more or less than 50%, because this data point has a relation to this mean. It's either greater than the mean or less than the mean. Or it could be, of course, it could be equal to the mean. But if the data point is here, the mean, of course, is in the middle. Then if it's less than, well, then that's less than 50%. If it's greater than, well, that's going to be greater than 50%. So you identify the data point, and in conjunction with the mean. So then, after you do those, convert to a z-score. Remember, z, x minus mu over standard deviation. And what that does is tell you how many standard deviations away from the mean that this x value is. It gives you that many standard deviations away, however many that is. So you do that, and then convert. Draw the picture and shade it to 3. Look up the probability on the table. This is when students, for some reason students and I have a difficult time communicating this, because they all say, which table, how do I look it up? If you draw these pictures correctly, you should know. Right now, if it's going to be greater than, less than 50%, which table to look it up, whether or not to ignore the negative, and then That's the answer. Check it by looking at the picture. That you drew over here. And that's what you do. That's all you do. Okay, I'm going to 5 minutes. Erase. Let's erase the board, and we'll do one example. This looks like it's going to turn in about 8 minutes. Okay. Example. IQ. This is called intelligence quotient. You've all heard of it. It's a psychological phenomenon that they made up back in the 40s. I have a lot to say about that, but I won't right now. But IQ, it has a mean of 100 and a standard deviation of 15. This IQ score that these psychologists came up with. So therefore, that's 100. What we're saying is, here's 115. That's one standard deviation away. 130. I did two 15s there. That's 2. 145. Notice the population with an IQ greater than 145 is it's nearly non-existent. And then going the other way, of course, is 85, 70, 55. And again, it's symmetric around this mean. So that's what the picture looks like. So let's just do some examples. What's the probability somebody has just any person in the world has an IQ, say, less than 85? Less than 85. That's a question. That's the question. That's what you're supposed to do. Okay, so identify the mean is 100. Identify the standard deviation is 15. X is less than 85. So the picture, here's 85. Here's the mean. Less than is right there. Right now you know it's less than 50%. Right now you know which table to look at. Okay, so get the z-value. Whoops. Which is x, 85 minus 100 over 15 is negative 1. You look that up and you get almost 16%. 1587, I think. 15.87% have IQs less than 85. Stop. It's 8 minutes.